Stan Gibilisco here, proprietor and operator of amateur radio station W1GV Whiskey 1 Good Vibrations. I have printed out an email from a viewer, and I told him I'm moving kind of slow lately and it might take me a while to get to this, but as I read through this, I just couldn't resist. I find the whole subject fascinating, and I think that you might find it interesting as well. A lot of you may find yourselves in the situation that this viewer finds himself in. He rents, apparently a condominium or an apartment, in an area where the soil is very sandy or rocky, so that its conductivity is just horrendous, as I understand it. Almost completely sand. I lived in Minden, Nevada for a while, and I can certainly identify with that conundrum. And I rented a little guest house, but I didn't try to get on the air at that time. He says that one of his favorite authors recommends, or almost demands, that you use an 8-foot ground rod. You must use an 8-foot ground rod, he says. Then he says one of the answers on the extra exam test says to use 3 or 4 3-foot copper ground rods connected together. I don't know what the other answers, other choices were on the exam, but apparently that was the best of the bunch. But I think that, and he says, my idea is to use one large copper pipe, drill small holes in it, and then fill it with rock salt. Well, in my opinion, that's a better way to go than either of the two foregoing. But it's still not very good, because eventually, I assume you're going to pour water down the pipe or something, and eventually that rock salt's going to run out and leach out. And when you have sand as your soil, the conductivity right at the ground point of the antenna is not the only issue. The whole region of soil around the antenna also matters, and there isn't much you can do about that other than lay radials down on the ground, make them as long as you can within the constraints of the property line, and bury them if you can, just to keep people from tripping over them. People like Stan Gibilisco, who would, if he came into the vicinity, fate would have it that I would trip over it. I would have to. It's a cosmic law that Stan Gibilisco would trip over it. So bury it, in case they ever come to visit you. But seriously, I would use the largest diameter copper pipe, and as long as you can make it, but dig a post hole. Get a post hole digger, like one of those utility pole diggers. Use that thing to dig a hole down there and fill that up with salt. Pour water in there, and then, well, you put the pipe down first, and then you fill it up with salt. That'll help for quite a while. I'm assuming that you don't want any plants to grow anywhere near your antenna, because if they are there now, they aren't going to be there very long. But I would, in addition, install as many radials as you possibly can. It doesn't matter whether they're bare wire or insulated wire. It doesn't matter whether they're aluminum or copper or whatever, as long as they make good contact with that ground rod, and then bond the braid of the coax to that ground rod and to the radials by tinning the braid first, and then using hose clamps are pretty good for that purpose. You can, whatever will give you the best conduction between the braid of your coaxial feed line and the ground rod and the radials. It doesn't really matter how long the radials are. in the constraints of your property line. What really matters is that you just fill up that ground with as many radials as you can. I mean, ideally, you would just copper plate the whole thing, but that'd probably cost you more than you want to spend. And how to do it? Do I strip off some of the insulation near the corrector? Yes, you would solder the braid and then connect it to the ground rod. Next, he asks about a lightning arrestor. Should it be directly under the antenna, or should it be at the rig? Well, in my opinion, you should put the lightning arrestor at the radio end of your feed line, and make sure that you have a good electrical ground for that lightning arrestor. And that means the electrical ground of your house, whatever. And make sure that it is a solid electrical ground. It doesn't have to be a good radio frequency ground, but it has to be a good electrical ground. But, all that said, whenever you're not using the antenna, disconnect the coax from the radio and ground the center conductor of that coaxial cable to the same electrical ground that you would use for your lightning arrestor. You do not, why give electromagnetic pulse energy any opportunity to do damage to your radio if you're not using your radio? Unscrew that coax directly from the back of the radio or the transmatch, as the case may be if you prefer to use a transmatch. It doesn't matter then whether you have a lightning arrestor at the antenna point or not. You can put one there if you want, an extra one. It really doesn't make any difference. But you should put the lightning arrestor at the radio end, because electromagnetic pulse can get into your feed line however hard you try to prevent it. So don't let it get into your radio. Finally, the coaxial cable feed line length. I have read that the connection from a vertical antenna to the radio should be as short as possible. I also read a reviewer who mentioned that he had talked to the designer of the antenna, which will go unnamed, and that designer said the coax should be at least 100 to 110 feet long. I have no clue as to why it would be necessary to do that. I cannot imagine why that would be the case. Now, maybe I'm missing something. I'm certainly not going to call myself a guru. These are the ways that I would do it if I were in your situation. Make the feed line as short as you can and use the lowest loss cable that you can possibly find. Even hard line, if you can afford that. The best you can get. If I use the longer size, should I make a choke of 24 or 25 turns of the coax around a 4-inch diameter form? This would be near the entrance to the house to help limit common mode currents, correct? I would say yes, but it depends on the length of your feed line. If you happen to be near a current node or a voltage loop where your common mode current would be very low and your impedance for the common mode current very high, that choke might not do very much good. So I'd put several chokes at intervals along the line. Just make sure that they are not an integral multiple of a quarter wavelength apart. Those are just some little asides. That this is the way I would do it if I were you. Thanks in advance for any comments. I cannot tell you how much I have learned from your YouTube videos. Well, I'm glad somebody got something out of them. That's what I do them for. At least the ham radio ones. Well, all of them, you know. I got to get off this political ranting that I tend to get into. There's so many nut jobs in high places that I can't begin to tell you. I'm just a nut job in a low place. I won't even mention radials. He concludes his email with that. Well, I did, because I think radials may well be the very most single most important thing that you can do to optimize the efficiency of your RF ground when your soil is rotten, sandy, like yours is. So he says all the best, and I say 73, same thing. From Stan Gibilisco, W1 Good Vibrations, who will always conclude a QSO in CW with da-da-da-da-da-da.